Nernst equation. Now what is Nernst equation? Usually when electrode potential is calculated, it is assumed that metal is dipping in a solution of metal ions and the concentration of the metal ions is 1 mole per liter or 1 m. But when the concentration is not 1 m, it is either greater than 1 m or less than 1 m. Consider the electrode reaction. Metal ion having n units of positive charge plus n number of electrons forming solid metal. Now here the metal ion concentration is not 1 m. So the electrode potential at any concentration measured with respect to standard hydrogen electrode will be equal to the electrode potential or the reduction potential will be equal to standard reduction potential minus RT by NF. Here N denotes the number of electrons, natural log of concentration of the product divided by concentration of reactant. Since the product is solid M, its concentration is taken as equal to 1 and the equation becomes electrode potential is equal to standard electrode potential minus RT by NF, natural log of 1 by concentration of the metal ion. R is the gas constant, F is Faraday's constant, T is the temperature in Kelvin. Value of temperature is 298 Kelvin. In Daniell cell, the electrode potential for any given concentration of copper and zinc ions. Now, the chemical equation for the Daniell cell is Cu2 plus ions plus zinc forming Zn2 plus ion plus copper. Copper is the cathode and the reaction at copper is Cu2 plus 2 electrons forming copper atoms, and zinc is the anode and reaction at the anode is zinc changing into Zn2 plus ions plus 2 electrons. So for cathode the electrode potential is equal to standard electrode potential minus RT by NF. Here value of N is 2. N is the number of electrons and number of electrons involved is 2 here. So value of N is 2. So RT by 2F, natural log of 1 divided by concentration of copper ions. Similarly for anode, electrode potential of anode is equal to standard electrode potential of zinc minus RT by 2F, natural log of 1 by concentration of Zn2 plus ions. Cell potential is equal to E cathode minus E anode. Here cathode is copper and anode is zinc. So putting the values of E cathode and E anode from equation 2.9 and equation 2.10, this is the equation obtained. Rearranging the equation, the final equation is E cell, that is EMF of the cell, is equal to standard EMF of the cell. Here E cathode, standard electrode potential of cathode minus standard electrode potential of anode is equal to E cell minus this part of the equation is rearranged and it is equal to RT by 2F, natural log of Zn2 plus ions divided by Cu2 plus ion, concentration of Zn2 plus ions divided by concentration of Cu2 plus ions. So E cell is equal to standard EMF of the cell minus RT by 2F, natural log of concentration of Zn2 plus ions divided by concentration of Cu2 plus ions. Now EMF of the cell depends upon the concentration of zinc ions and copper ions. EMF of the cell will increase with the increase in concentration of copper ions and it will also increase with the decrease in the concentration of Zn2 plus ions. Now what is this 0.059 by 2? When natural log is changed into log to the base 10, the value of 2.303 RT by F is equal to 0.059. The equation for E cell becomes standard electrode potential minus 2.303 RT by NF log Zn2 plus ions divided by Cu2 plus ions. Now the value of 2.303 RT by F is 0.059 and value of N is equal to 2. So the equation becomes EMF of the cell is equal to standard EMF of the cell minus 0.059 by 2 log concentration of zinc ions divided by concentration of copper ions. Now number of electrons should be same for both the electrodes. So considering the following cell. Silver is acting as the cathode and nickel is acting as the anode. Reaction at the anode is nickel losing 2 electrons and changing into nickel ions, and reaction at the cathode is silver ion accepting 1 electron and changing into neutral silver atoms. Now number of electron lost by nickel is 2, but the number of electron accepted by silver ion is 1. So to make the number of electrons same, the reaction at the cathode is multiplied by 2. So this becomes 2Ag plus 2 electron forming 2Ag. Adding these two equations means reaction at the anode plus reaction at the cathode. This is the cell reaction obtained. And the Nernst equation can be written as EMF of the cell is equal to standard EMF minus RT by 2F. Here 2 is the number of electrons, natural log of nickel ions, concentration of nickel ions divided by concentration of silver ions raised to the power 2. Why 2? Because the stoichiometric coefficient of silver ions is 2 in the balanced equation. Now for the general electrochemical reaction of the type A moles of A plus B moles of B forming C moles of C plus D moles of D, number of electrons involved is N. The Nernst equation will be equal to EMF of the cell is equal to standard EMF minus RT by NF, natural log of product of the concentration of the product divided by the product of the concentration of reactant, and each concentration term is raised to the power which is same as its stoichiometric coefficient in the balanced equation.